Okay, dokie. Welcome to another um, video on data structures and algorithms with Open Delta. In this video, we're going to be talking about how to improve the speed of an algorithm using what we've learned before in the previous video on with big O notation, right? So let's jump into it. So let's just recap, right? So in the previous video, we are able to establish that the big O notation provides us with an objective method or way to compare the performance of two competing algorithms, right? So it allows us to, to have an easy way to say, okay, now this algorithm is not as good as the other one, right? And we got introduced and we analyzed the binary search algorithm, which was in the second video. And then in the previous video, we analyze that algorithm using big O notation, and we're able to establish that it is a O or it's a log n or log n algorithm. And we established that this is much faster than the linear search algorithm, which is an O n, right? But not as efficient as a constant time, but we already spoke about that, right? In this video, what will we be doing? We'll be talking about quadratic time algorithms. I'll speak later on that, what that means. To do this, we will go through a classic algorithm in computer science, right? This is the bubble sort algorithm. We'll look at that. I'll explain that with some diagrams, and then we'll code it out in Python. And then we'll look at a way of how to improve an inefficient algorithm using big O. And the inefficient algorithm will be one that is of quadratic time. I will explain that further in the next video. Sorry, in the next section. Right, sorting algorithms. Right, so what are sorting algorithms, right? Essentially sorting algorithms. There's been tons of sorting algorithms across the years in computer science, and they're essentially trying to, like the name suggests, right, arrange an array from least to greatest or from greatest to least, right? So that's the whole purpose. They become quite efficient, but the ones that we're going to talk about is the simplest one, bubble sort, which is not the most efficient, but is just an introductory sorting algorithm that you would come across in a data structures and algorithms class, right? So now what is the bubble sort algorithm, right? All sorting algorithms essentially trying to solve this problem, right? Given an array of unsorted numbers, how can we sort it so that it ends up in ascending order, right? So that's what we're going to be doing in this video, right? So I'll just break down the bubble sort algorithm, right? So we have an array from our previous videos, and in this array, in this problem, what we're going to do is initialize two pointers, right? That first point to the first two items in the array, right? So we have the first pointer pointing at index 0 and the second one pointing at index 1, right? And then what we do is we compare item A and item B, and that should be index 0 and index 1. And if the value at pointer A is greater than the value at pointer B, right? Like we have in this case, we're going to swap them, right? So in this scenario, 5 is greater than 2. So 5 should go to the right. Yeah, should go to the right, and then 2 should go to the left. If not, we do nothing, right? That's the algorithm right there. So after we do that, we move the pointers to the right by one step, and then we compare again, right? And you can see, is 5 greater than 6? No, it's not. We do nothing. Move to It's 6 greater than 10? We do nothing, and that's it. We have our now sorted out an array in ascending order, and this is considered as a pass through, right? And essentially, what this comes about is like in a more we'll see in the next slides, but like we don't know what the problem is. Like it's not so easy to code this out, right? Because what we don't know is how many pass-throughs will we have to go through to get this algorithm in or this array, sorry, in this array in order, right? So that's one of the problems, right, that we have to kind of figure out. But that's essentially the first step that we've gone through. So this is a pass through. In the first pass, we're able to sort the array from least to greatest, right? So um, great. So now we have a larger um, array. In this array, we have 5 items, right? So just like before, we're going to start with our first pass through, right? We initialize our pointers, one at index 0 and one at index 1. And then we compare and see that 8 and 4 are not in order because 8 is greater than 4. So what do we have to do? We have to make a swap. That means we have to take 8 to the right and bring 4 to the left, right? So we do that. That's step 2. Step 3, we move our pointers again to the left, to the right, sorry, and then we compare 10 and 8. Okay, we see that 10, 8 and 10 rather, 8 and 10 are in the correct order, right? So we move, then we check 10 and 3, and we see that they're not in the correct order because 10 is larger than 3, right? So we have to make a swap, right? And then we continue. Then we do 10 and 5. We see that it's not in the order that it's supposed to be, right? And then what do we have to do? We have to make a swap again, right? So 10 goes to the right and 5 goes to the left. And then that's the end of the first pass through, right? So what happens in for each pass through, right? Where the name bubble sort comes from, like the largest value, the highest unsorted value bubbles up, bubbles up to its correct position for every pass, right? So in this first pass through, we have 10, right? That has bubbled up the highest value. Now we need to get 8 into its correct, then 5, then 4, right? So we move on. We do the same thing, right? Do the same thing again. We switch, right? Not in the right order, switch. Now, okay, we check. Okay, it's in order, therefore 8 is now in its correct position. End of pass 2, right? And we go to pass 3. We check, okay, not in the correct position, switch. Not in the correct position. Is it in the correct position? Actually, it is in order, right? So that's the end of that pass through. Then we go to pass 4 and we just have to check and see, all right, great. If we do not have to make a switch, right? Because remember in this one, we made a switch in pass 3. And then if we do not have to make a switch in a pass through, then we know that we've like completed the task, right? So everything is in the correct order. And that's what we have here, right? So now our array is completely sorted, right? And we had to do this, and we had 4 pass-throughs, and there were 16 steps, right? So now, like, how can we implement this in Python, right? So let's jump to it. Okay, dokie, let's jump into it, right? So now we want to implement this in Python. So I'm just going to start. I'm going to say bubble sort. We have an unsorted list, right? And then we just put some typing there. And then we're going to return a list, right? Sorted. Okay, now we're going to initialize an index, right? Initialize an index to keep track of unsorted, right? Array, right? So this will help us know that, okay, have we sorted our array, right? The index until it's been sorted, right? So that makes sense, right? So we're going to call it unsorted until index, right? It's going to be the length of the array, right? And then I'm going to call it -1, right? Because yeah, because we have 2 pointers, and then we don't want the last pointer, the first pointer, pointer A, if you remember the slides, to get to the last item in the list, right? So now we're going to assume that assume the array is unsorted at start, right? Should be. And we're going to say list sorted is equals to false, right? And then while not list sorted, while not false, which is true, right? We enter our while loop. We are going to now flip that, right? We're going to assume that it's going to be sorted, set the, you see why? Set the list to be sorted. And we say list sorted is equals to true, right? Now we're going to do now, we're going to say for index, right? In the range of unsorted until the index, right? Also going to check, and I'm going to say if our unsorted list, right? The index at which we're at right now is greater than our unsorted, right? So list, no, unsorted list index +1, right? So if this value, if the preceding value is larger than the following value, preceding, what's the opposite of preceding? Following, yeah, value, succeeding, I think. Yeah, forget the English, right? We'll know that the list sorted should be, it's not sorted, so we're just going to flip it back false, right? And then we're going to do the sort, and then I'll just paste this because it's quite long to type, and we'll just do that, right? Once that's done, then we're going to decrement our unsorted, we're going to decrement our unsorted until list index, right? Remember, for every pass through, the highest value is bubbled up, right? So now we know that when we got here, we know that the largest value has been let me repeat that. By the end of this array, by the end of this for loop, we know that the largest value has bubbled up to the top, right? So we don't have to worry about that. So we decrement. Okay. Then once that is done, right? And that is done. Okay. So this is always going to run until we get to 1 or 0, right? And then we'll know that our list will be sorted, right? When will we know our list will be sorted? So I can explain that further again, because we wouldn't have to do a swap. Remember in the video, I said that if we go through a parser without doing a swap, that means it's been sorted. So this would be true, and then we wouldn't have to do any swap here. So it'll just end, and then um, what I want to do, then we'll exit this loop, right? So not true is false, so it doesn't enter that. And once that is done, I just want to say it's a sorted list is equals to unsorted list, all right? By the time we get here, this will now be sorted. So I just wanted to return it in that format so it reads better. But you could just return to the unsorted list. Okay, sweet. So now we can run this in our interactive window by just selecting and shift enter, right? And then we can have some random okay, that. And we're just going to test it out, right? And to do that, we just do shift enter again. As you can see, it has been sorted from from um from highest from lowest to highest, right? Cool. Okay, and then just to test it again, um, right? Let's say this. Just gonna do range 100 to 2. We're gonna say 2. Why not? Right, and then we can run that. And that should be a list. So what that is doing is saying from generate a list that goes from 100 and ends at 2 with a step of 2. So 100, 98, 96, 94, and so forth, right? If that makes sense. Or not, or not, or not, or not. What? Okay. Alrighty. Okay, what's cutting there? Let me. Okay, so okay, something's cutting it now. Like if you were to check it here, what? Okay, that is not supposed to be there. Remove that. Go back. Do that. Do that. Okay. Okay. This is start, stop, step by 2. You can't go to 2 by +2. Take that's the right. Great. Okay. Now let's reverse that, right? So we can say uh list B is equals to bubble sort B list, right? And then we shall see what that looks like, friends. List B, right? Sweet. I should see from 2 upwards. Okay, something went wrong. What happened to 2? Oh, because 2 is not inclusive, right? So it stops at 4. Right. But anyway, you get the point. So yeah, so I was able to do that. And this is actually the worst case scenario, right, that you could probably have in using this type of algorithm. When you have and each when you have like from where the list is from actually from um is in descending order, right? It's in descending order. So this kind of a worst case scenario when it comes to the bubble sort algorithm efficiency. Right. So let's jump back into the slides and I can explain further why this is the worst case scenario. Great. So bubble O, let us analyze the bubble sort algorithm using the big O. Right. Okay. So to begin to analyze the bubble sort algorithm, we have to understand that there are 2 steps kind of being performed or 2 actions being performed in this algorithm, right? Um, the first one is the comparison, right? Where we're comparing the numbers to check which one is greater. And then the second is like the swap, right? So now how many of those do we do for n element is what we're going to get to. Right. So if we look at our example, right, we had five five values in our list, right? And in the first pass through, we made 4 comparisons, right? Um, the first one. So this is one, okay, one, two, three, four, right? And the second, we had to do one, two, three. This one's already sorted. Then third, we had to do one, two, sorted, one. Okay, so that's how it kind of works, right? So we had to do 10 comparisons for a five element list or array, right? And generally speaking, that's you would write it like this mathematically, n minus one up to one, right? So let's move on. Now, when it comes to the swaps, right? We're going to go to the worst case scenario, where you have a swap for each comparison, and that's when it's actually arranged in the opposite way, which is from descending and then descending order, right? So in for each comparison, we may have to make a swap, right? So if in the previous one we had 10 comparisons, there will be 10 swaps, okay? And we can show you this in a graph, right? So we've been doing this tables for a while. So this is like before number of elements. If we had 5 elements in here, we would do 20 steps, right? 20 steps. And this is the n squared, right? So think of n squared as quadratic time if you ever dealt with calculus or anything with a square and solving the roots. So if you're in maths, remember you have your quadratic um, functions or quadratic graphs into the square, right? And as you can see that the bubble sort algorithm gets close to this, right? To the quad to the square of the number of elements, right? So we kind of say that this algorithm is a quadratic time has a quadratic time efficiency, and it's not really the most efficient algorithm, right? It's quite inefficient, right? As you can see, this is O of n, right? And you see how that compares to that for 5 elements. You see like the vast difference between the number of steps for a linear time algorithm compared to a quadratic time algorithm. Okay, so whenever you see that you are dealing with a quadratic time algorithm, right, your alarm bell should be ringing on saying that how can you make this more efficient? Okay, cool. So now we're going to try and essentially it's a Python code break. So we're going to use big O to optimize um, an inefficient algorithm, right? So let's jump into it. All right. So before we've done the search, right? Where we're looking for a particular value. We have tried the sorting and we're trying to sort in ascending. Now we're going to check for duplicates, right? We're going to see like um, if a duplicate value exists in an array, right? To do that, we have this function that I've already created for you, right? So how this works is we're going to iterate through each value of the array using I, and then for each value, we're going to run another for loop, right? Through the array using J, yeah? And then we're going to check if this value I and J are the same, and if they are, the array has duplicates, right? So if we complete the loop without encountering any duplicates, that means we can return false and say that they know duplicates. Maybe I should rewrite this to has duplicates. But anyway, um, it's too late now. I should probably call this has duplicates so that it's answering the question. It's asking a question, and then our return value is answering that. Okay, so we have our steps that we're going to check. We're going to check how many steps this takes. And this is our first for loop, right? So we're going to get the length of the array, and then we're going to do that again, and then we're going to increment, and then we're going to check. Um, And this says that if I is not equals to j, because we're doing this over the same array. Like so if they're the same, they're going to get the same value. So if this is not this, all right, it's not this case, and the values of I and j are the same, return true. Okay. Okay, so that's that. We have A1, 2, and 3. And in this scenario, is this the worst case scenario? Could be, should be, because we have to go through everything to see if it has duplicates, right? Um, yeah, it is. You have to go through the entire list, and there's no duplicates, so it's kind of is the worst case scenario. But okay, and then we're going to say we should get a false, and as you can see, we got false, and then we got 4, so we got 16, and that's because this is like a quadratic time algorithm, right? So what is essentially happening for each element that we have, right? We can at least square it, we square it, so you know, so this essentially happens. when you have a nested for loop, right, you'll get a quadratic time algorithm. So if you see yourself writing a for loop within a for loop, try and see if you can like find a different solution, right? And let's just see that the algorithm works or this function works. Okay, and then we should not be up to 16. Should be less than that. True. Okay, it doesn't return how many steps if it's in true. True. It should do that actually. Print steps. Okay, and remember this is the interactive Python window. Shift enter, and then you can kind of operate your code as like a Python Jupyter notebook if you want that experience. Okay, and it took 24 steps, and that's because we increased the number of elements, right? So, and the value of the was at the last duplicate was the last, right? So this is 1, 2, 3, 4, 5, right? Last one, okay. So we probably got to this one for I, and then 1, 2, 3. So got to I. So what's this? 4 times 4 is 16. We together. 4 times 4 is 16. We together. 17, 18, 19, 20, 21, 22, 16. Okay. Okay, no, excuse me. Got to here. Okay. Then we got to here. We got to here. I'm just trying to figure out we got to 24. Because I'm tripping now. This is 6. Okay. 1, 2, 3, 4, 16. Okay. 16, right? 16. So we had 4. We got that. Oh, sorry. Remember, this is 1, right? Count 1. Then 1 has to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right. So by the time we get to here, we've done 18. 19, 20, 21, 22, 23, 24. That's how we got to 24 steps. Okay. I was tripping there. Tripping, 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 tripping. But we got it. Cool. Now let's try and improve this, right? So if you see you got the for loop, let's try and do this without a for loop, right? So we define another function, right? Array, same way. Okay. This would be check or high has. Then we create a dictionary called same before. And then we just like before we have our steps, set it to 0. Okay. For that, then we're going to say for value in our array, right? It's going to loop through it, going to increment for the loop. Now I'm going to see, does this value, is it in this dictionary? Does this value, is it a key in this dictionary? If it is, then we have a duplicate. If it's not, we add it, right? We add it as that, right? So we say this value is a key and it's this value, right, is a key in this dictionary and its value is 0. I hope that makes sense. If you're following, if you don't know about dictionaries, you can check out my Python fundamentals course, right? And then we print the steps, right? So if we go through all of this, then, and we get here, that means there were no duplicates, okay? So let me just do that, say that again. We have a dictionary, empty dictionary, initialize our steps at 0, run a for loop, right? And in Python, this is saying for value in array, right? So for each value, I think that's how it works in JavaScript. I'm not sure. For each, right, item, something along those lines, right? So I want to unpack every single item in that array, right? And I'm going to check, is this value in my dictionary as a key? If it is, return true, right? If it's not, remember, if this doesn't enter, if this condition doesn't check, we go to the next line, right? And then we add it, right, as a key. And the value for that key is 0. Then we continue again, continue, 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 continue. And then once we finished iterating through our array and we didn't exit, then we would have to exit with a false, saying that there's no duplicate, right? So then we can just run that quickly. 4 steps, right? Compared to the 16 that we had before. And then you just say 5, 4, and let's see how many. And like before, I should print steps. Okay, I'll run that again. Took 6 steps compared to 24, right? And then the more efficient way to do this, I think, right? Python, it was a built-in Python function with the help of built-in Um, right then, right? Options. Okay. So what this does, right? Check duplicates three, right? I take my list and I say has duplicates, right? A variable. Right, it's going to be a boolean, right? I calculate the length of my array, right? And then I then say to my array, convert it to a set. And if you remember what a set does, it doesn't allow duplicates, right? And then I calculate the length of that result. And if they are equal, right? If they are equal, it should say no. Wait, have I written this correctly? Let's check. Right, so if these two things are equal, mm, then they are no duplicates. True. However, if they're not, false. Right, so let's do that again. And then three, then run it. It should be true. What? Yeah, it doesn't go wrong. Has duplicates. Yeah, it's what's cutting it. Has duplicates. Yes. Length of array. If that's the same, the lengths are the same. If the lengths are the same, then they are no duplicates. Right, because and if they are the same in this way, it's going to return a false because they're not the same. So it should be like this. Let's do that again. Sorry about that. Right. Okay. So if they're not the same, then we know that because this one has duplicates and this one will not have duplicates. So if they're not the same, uh, right, it will return true, and that means it has a duplicate. And if it returns false, it means it doesn't have a duplicate. Hope that makes sense. Makes sense to me. Makes sense to you. And yeah, that's pretty much it for this video. So let's just jump back to the slides and see what's cutting on that side. All right. Yeah, that's pretty much it. See you on the next video. Cool. Cheers, guys.